Hello, so you can see the holes match on the edges, but not in the middle for the T-type screw nut converter, which is going to be a problem. So I could either drill some holes in the nut converter and tap some thread in, tap some thread even, or drill some new holes in the aluminium plate. I could do that in my garage with my shoddy drill, or I'll get my mate with the machine shop to do that. Next, new power supply, power adapter for the remaining motor. Get some wire cutters. It's a mobile phone charger, 1.5 amps. No, is it? No. 5 volts, 300 milliamps or something. I don't know. Doesn't matter. Not at the moment. Anyway. What we're showing here is stripping the wire, using the wire strippers, and connecting to the DC connector. The whole point of using the DC connectors actually is so that when I'm troubleshooting, I can swap them between the NEMA motors, the stepper motors. So if one has a problem, unplug it, try the different power adapter. I forget the power rating of the motors, but yeah, I think apart from the Adafruit one, the other two can take 1.5 amps. When I stripped this down, I had the silver wire on the outside, then there was the plastic sleeving, and then there was more wire in the middle. So I had to strip quite a lot back, bend it over to double the thickness so that the screws had a bit to grip onto when I pushed it into the connector. I could have soldered, put a blob of solder on the end of each lot of strands, but it seemed to work okay with that, so there we go. Undo these little screws, ready to take the wire. One is plus and one is plus 5 volts, the other is ground. So you do need to get them around the right way. If you get them around the wrong way, it doesn't blow anything up, so don't worry. Try it one way, if it doesn't work, try the other way. I'm sure you could look online and find out which is plus and which is ground. I've got a bit of a habit of just trying things rather than researching them. But I know from experience that there's never a problem if you get these round the wrong way. So it's quicker to try it rather than spend 5 minutes looking on Google. Right, so ready to power up the third stepper motor, which will be the Y-axis. I bought this because I was trying with 12 volts and I was getting a flashing LED on the L298. Even though I'd wired it up for 12 volts, it didn't like it, really didn't like it. It was making a sort of a clicking noise and it was getting quite hot. And as you can see, nothing lit up here, so that was because I had them wired around the wrong way. So yeah, I quickly just swapped the wiring around and then I was in business. 50-50 chance of it working, and it didn't. It's a bit like dropping your toast. Drop your toast on the kitchen floor and it lands butter side down, doesn't it? There we go, working. That's after I'd swapped it around. The red LED is not quite so bright on that one. I think that's because there's less current coming through that power adapter. I think it was 300 milliamps, 5 volts. Not much power at all, so yeah, there's a fair chance that well, the motor for the bed, the y-axis motor, actually was just spinning anyway. So that's the next problem, is we're about to find out. I've made a script expy which runs x, y, and z scripts. It imports all three scripts into the ex file and then runs them. Z works. Y doesn't, and makes a noise. You feel it attempting to turn. And X works, that's using the adafruit hat, and that's only using 5 volts and 350 milliamp Nemo motor, so I don't think lack of power is a problem on the y-axis, so I need to investigate the sequence of the wiring. I suspect I've probably somehow, where I've extended the cables and ended up getting the colours confused, I've probably got it connected the wrong way. I actually disconnected the screw thread, so there was effectively no load on the motor, and it still didn't turn, so that at least means it's not an issue with lack of power or the current's too low. I think it is just my wiring, which I'm going to check, which will be fun. You can see the bed. Next, 4 new holes, which I think I will get contact of mine to do, because if I try and do it in my garage, I will bodge it with my hand drill and it will be rubbish. So yeah, that just flashed up to remind me to, I need to buy some, I think it's called braid, just to tidy up the cables. On a bigger CNC, you get the, looks like caterpillar track plastic, I forget what it's called, but it's cable management really. I'm not going to go to that expense here, but if you've seen any 3018 CNC engravers that you can buy from Banggood, there's one called the Genmitsu and there's another called Sane Smart. They're the brand names, same machines to all intents and purposes. They come with braiding, which tidies up the cables. To be honest, these could just be left as they are, but it's just going to look nicer. So I'm going to leave it here. All I've got left to do is attach the bed and sort out that the y-axis motor, why it's not turning properly, and then we should be in business. I should be able to at least attach a pen to the z-axis and maybe use it as a plotter just for test runs before I get the spindle motor, this 775 spindle motor, and then my the problem for that will then be attaching the spindle motor to the z-axis. If I really bodge it, I could use cable ties, but I think I'm going to end up having to source some kind of proper clamp to do the job properly. I've got this far, so yeah, I might have to do that. There are, I know the 30118, the engravers, they come with, the clamps on those are 3D printed. I probably could source one of those, as the aluminium clamps, it's probably overkill, and they're quite expensive. They're at £14, 14 quid, pounds. GBP in dollars is probably, I don't know, 18, 20. And in euros, who knows? There we go. The bed will be attached in the next video and the motor will be working. Thanks for watching, and please subscribe because it's good for you. Bye!